Okay, so today let's talk about section 2.4, circles. So in the first part, we are going to write down the standard form of the equation of circle. Okay? Write the standard form of the equation of a circle. Okay, so circle is almost the simplest curve in the xy plane, except the line. Line is also the most simple one. Okay, and then you will consider circle. So first, let's see the definition of the circle. What is a circle? A circle is a set of points in the xy plane okay, so a circle can be placed in whatever plane, but because we're going to use xy to write down the equation of the circle, so we place it in the xy plane. Okay, so it's a set of the point in the xy plane that a fixed distance r from a fixed point hk. Okay, so that's the definition. Fixed distance from a fixed point. So for example, you have a fixed point hk. Hk are the coordinates of this point. And you have a fixed distance r. You have this point. That could be a point on the circle. And you go here. It could be a point on the circle. You go here. It could be a point on the circle. Or this direction. Or even here. Or even here. Here. Or here. Okay? So all the distances are fixed r. Or even here. You get all possible such point, you connected them. You will form a circle. Alright? That's the circle, the collection of all these points. And in this definition, we have two fixed stuff. Fixed distance and a fixed point. So they have names. The fixed distance r is called the radius. And the fixed point hk is called the center of the circle. Okay, so here I want to emphasize the center is not part of the circle. Even though center is one of the important part, but it's not on the circle. Circle is just this round stuff. Okay, circle is this round stuff. Is center is not on the circle. All right. Now let's try to determine the equation of the circle. The circle has a unique condition, fixed distance from fixed point. We know that assume this xy is a running point on the circle. Then you have the center. The distance between the points hk and this running point xy is, what is the distance? We have the distance formula. X minus x coordinate, y minus y coordinate, and take square root. So this is a distance between these 2 points. And it is equal to r, so you let it be r. And that's the equation. That is a condition. That is a geometric condition. This is a geometric condition. And we satisfy it, and all the solutions of x, y will give us the points on the circle. But in algebra, we don't like the square root, because square root is not easy for us to compute, right? Or it is hard to write, like you have this long line. Okay, so since we don't want square root appear in the formula, so we square 2 sides. We square 2 sides, then what we get? We get x minus h squared plus y minus k squared is equal to r squared. Is equal to r squared. And this is considered, well, first of all, this equation is equivalent to the original, this one. This equation is equivalent to it. You can go back. But this one is better. We consider it better because it has no square root. It's all just square. Square we can compute by hand. Okay, so we will consider this as a so-called the standard form of the equation of the circle. Okay, so let's write down the definition. The standard form of an equation of a circle with radius r and the center hk is x minus h squared plus y minus k squared is equal to r squared. Okay, so we just copy this. So this is the standard form of an equation of a circle with the radius and center hk. So let's study this standard form. The right side is r squared, is always non-negative, positive, always positive. R squared is always positive. And left side is a sum of 2 squares, x minus h and y minus k. They both square. Whenever later you see some equation like this, you should realize, okay, its graph is a circle. Okay, so whenever you see some equation like this, you should know it represents a circle. And also be careful, this right hand side is r squared, not r. It's r squared because we square 2 sides. Okay, so that's the standard form. And when we have this circle, we said it has a center hk. Basically, we place it at the point hk. Of course, we can move this circle around any place. And we want to study circle, so if we want to place it in a special position, if we study a circle, we want to place it in a special position. Which position is special? The radius, of course, you cannot change the radius, because if you change the radius, you get a smaller circle or you get a larger circle. That's different. But if you do not change the radius, you can change this fixed point, like you shift or translate this circle. We consider if we place the center at the origin, it will be special. Why? We place the circle centered at the origin. Because if we place it centered at the origin, then hk both 0. Origin, x coordinate 0, y coordinate 0. If hk are both 0, then x minus 0 is just x, y minus k is just y. Okay, so that is what we mean special. Okay, so theorem, let's put the argument we had in the theorem. The standard form of an equation of a circle of radius r with center at the origin. Zero, zero. You see here, we have to fix this radius, but we can translate this circle. So we move this circle at the origin. Then the standard form is x minus 0 squared, x squared, y minus 0 squared, y squared is equal to still r squared. Okay, so that's the equation centered, the equation of the circle centered at the origin. All right, next, even among those special placed circle, we consider one even more special. Which one? We let R be number one. One is the unit, like, right? One is a unit. So that's why we consider it even more special. If the radius R is equal to 1, the circle whose center is at the origin is called the unit circle. Okay, and has the equation first. The center is at the origin, so you're going to check this formula: x squared plus y squared equal to r squared. And second, r is a 1, so r squared is a 1. So the equation is x squared plus y squared is equal to 1. This one is 1 squared, okay, is the radius squared. So this is the unit circle, How do we sketch or graph a circle? First, you determine the center. You get the center. And second, you go top, bottom, right, left, r distance. Okay, r is 1, so go top 1, right 1, bottom 1. Bottom 1 becomes negative 1. Left 1 becomes negative. And then you try to use smooth curve to connect them. Okay, so that's a way to sketch the circle. You first get the center, then you go to 4 directions r distance, and then you connect those 4 points. That will be more or less the circle you can draw by hand. Okay, so this is a unit circle. Okay, so we already have so many, 3 different standard forms. This is a standard form for all circles. X minus h squared plus y minus k squared is equal to r squared. This is a circle, the standard form of a circle when the center is the origin. So it's a special. This is a standard form of the circle with the center at the origin, radius equal to 1. So it's like special and even special, right? This is just a standard form of one circle. This standard form a small class of circle. This standard form for all circles, right? So now let's see the example. The example, write the standard form of the equation of the circle with radius 5, and the center -3, 6, -3, 6. Okay, so you have the radius, you have the hk, then just follow the definition. So solution, the standard form will be x minus -3 parentheses squared plus y minus 6 parentheses squared is equal to 5 squared. If you want to simplify it, you can just put x minus -3 is x plus 3 squared plus y minus 6, y minus 6, y minus 6. 5 squared is 25. Okay, so in the exam, I want to emphasize, in the exam, both are correct final answers. So you can just write this and leave it, or you can just simplify it. But you do not expand square. You do not expand x plus 3 square or y minus 6 square. Okay, you never do that. Okay, another thing I want to say that from this example, you can see that inside the parentheses, it could be x plus 3, or it could be y minus 6. It can be plus or minus. Those plus minus depend on how do you do the subtraction. If you subtract a negative number, you eventually get a plus. If you subtract a positive number, you still have minus. Okay, so the equation has the property that inside parentheses is always x plus or minus a number, y plus or minus a number, and then square to those two terms, do addition equal to a positive number. All such equations represent circles. All right? Okay, so this is the first part. Find the equation when you have the radius and the center. And second, possibly you directly have the equation. You want to graph a circle. Graph a circle means you have to find the center, find the radius. So it's an opposite, reverse process. Graph a circle. Okay, let's see the example. Graph the equation x plus 3 squared plus y minus 2 squared is equal to 16. Okay. Okay, so first, it is a circle. The graph of the equation is a circle. It is a circle. Then the right hand side is r squared. The r is square root of 16 is equal to 4. Radius is from the real life. There's no negative radius. So the radius is always positive. The principal square root of 16 is equal to 4. So next, we're going to find the center. To find the center, you need x minus h, y minus k. Okay, so we're going to write x plus 3 as x minus -3 squared, y minus 2. Y minus 2 is still y minus 2, equal to 16. And from this formula, we know that the center is -3 and +2. So you must get a -3 here. Be careful about this -3. So when you try to determine the center, it's always x subtract y subtract, x minus y minus. You have to have this form literally so that you can find the right xy coordinates of the center. Okay, so you get the radius, you get the center. Now let's try to graph it. To graph it, well, let's see. First, we locate the center, -3, -1, -2, -3, +2 up, 1, 2. This is a +2. This is a center. So -3, -3, and +2. After you get the center, how do you sketch the circle? Remember, we have top, bottom, left, right, 4 points, and then connect them. So the radius is 4, so go up 4 units. 1, 2, 3, 4. This is the top point. Go down 4 units. 1, 2, 3, 4. Remember, you always start from the center. Go right 4 units. 1, 2, 3, 4. Go left 4 units. 1, 2, 3, 4. Okay, so you have this cross, then you're going to connect them. And that's it. That's the sketch of the circle without any other equipment. Okay? Well, it looks not nice, but well, I accept it. You should accept it. Okay, so that's a circle. If you observe this circle, you will see that it intersected the xy coordinates. When you intersect xy coordinate, you have intercepts, right? So the next problem, we're going to try to find those intercepts. For the circle, the same circle, for the circle x plus 3 squared plus y minus 2 squared is equal to 16. For the same circle, find the intercepts, if any, like all, if any, of its graph. All right, find intercepts. How do we find intercepts? To find x-intercept, find x-intercept means you only consider x. You do not consider y. What do you mean you do not consider y? Y is 0. To find x-intercept, y is 0. Y is 0, okay? So it's x plus 3 squared plus 0 minus 2 squared is equal to 16. 0 minus 2 is negative 2. Negative squared is 4. So x plus 3 squared plus 4 is equal to 16. You move 4 to the right side, it's 16 minus 4. So you get x plus 3 squared is equal to 12. Remember that whenever you have x squared is equal to a is positive, then x is plus or minus square root of a. That's the definition of a square root, right? Okay, so x plus 3 squared is 12, then x plus 3 is equal to plus or minus square root of 12. Okay, then you move 3 to the right side, it's minus 3 plus minus square root of 12. Negative 3 plus minus square root of 12. So you have two x-intercept, negative 3 plus square root of 12, or x is equal to negative 3 minus square root of 12. There are two x-intercepts. Okay, check here. This actually corresponds to negative 3 plus square root of 12, and this corresponds to negative 3 minus square root of 12. You do have two x-intercepts. Okay? Counterpart, let's try to find y-intercept. To find a y-intercept, we do not consider x, then x has to be 0. To find a y-intercept, x is 0. Then x is 0, so it's a 0 plus 3 squared plus y minus 2 squared is equal to 16. 0 plus 3 is 3. 3 squared is 9. So it's 9 plus y minus 2 squared equal to 16. You move 9 to the right side. 16 minus 9 is 7. So y minus 2 squared is equal to 7. Then y minus 2 is plus or minus square root of 7. You move 2 to the right side, then y is equal to 2 plus or minus square root of 7. So y is 2 plus square root of 7, or y is 2 minus square root of 7. So there are two y-intercept. This is a 2 plus square root of 7, and this is a 2 minus square root of 7. Okay, you see, it fits our sketch. And that is this include all intercepts, x intercepts and y intercepts. Okay, so x intercepts and y intercepts. So again, to find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. And then try to solve, either try to solve for x or try to solve for y. And here, when you have x squared equal to a, x is a plus or minus square root of a. Okay, so we finished the first two sections, and we will we finished the first two parts of this section. We're going to continue the discussion in the next video. Okay, thank you.